Alrighty then. Here we go. Alright, there's a little rule in calculus that says if a theorem has a name, it's really important it's going to come back to haunt you. Today we get 2.
That's all of math.
That's all of math. Good look for you.
Thank you.
Nice ornamentation. Rolle's theorem today, and the mean value theorem. Rolle's theorem is the introductory theorem, which has a lot of weird stuff associated with it, and then we get done with that and we move on to mean value theorem, which is the more practical and useful theorem that we're going to use. So we're going to talk about Rolle's theorem, and then we're going to talk about the mean value theorem, and you should be able to count to 10 in German.
I learned how to do that once,
Go.
and I don't know it anymore.
Well done. Is that all you know?
See.
See, great. Switch to Spanish. Is that all you know? Ja, or 9. What you going? 9, that's not all you know? Ja, that's all you know.
Ja.
Nicht sehr gut.
Guten Tag.
Ja, sehr gut, ja.
Da.
Ja, was
Yeah,
that's
that's
Russian.
Russian.
Yeah, that would be Russian.
There's a
Wait, what's that?
down.
What's that song? It's like something. I see a banana. Wait, da-da.
Do you know?
Sound of Music?
What did they say
From
though?
the Sound of
So
Music.
long,
There's
so long,
very well beat.
Oh,
Music.
So long,
I'm
farewell,
not proud
auf
of this fact,
Wiedersehen.
but I've never seen
Goodbye.
it. And it's my wife's favorite
Auf
movie.
Wiedersehen.
Half German.
It's when we end up in divorce court.
Auf Wiedersehen.
That will be the
That
main
will be-
reason we end
that
up there,
will be-
because I never sat down to
So
watch
many people
Sound of
told
Music.
me.
But I made her
So
watch like Sounds of
Oh,
Land.
it's
like, you know,
All the Batman movies.
Yeah.
Okay, so there's this guy Michel Rolle. He's a French guy, and this is the actual definition. So before I give you the English version, I want to break this down so that you understand what's going on. This is an if-then statement, and you'll recall from geometry that it's an if-then statement. The first part is called the hypothesis. The second part is called the conclusion. Irrelevant. But let's look at the hypothesis. F is continuous on the interval and differentiable on the interval. That makes sense, right? It's continuous. You can draw without picking up your pencil. It's differentiable, meaning we can find the slope of the tangent line at all the points. And then this is the new part. And if f of A equals f of B, what does that mean? First of all, what's f of A?
Function.
No.
1 point.
Be more specific. Value of? Good. It's the y value when f equals a, or when x equals a. So remember we talked about way back when, we're no longer talking x comma y in this class, we talk x comma f of x. So now we're talking a comma f of a. And then we've got f of b. What does f of b mean? Bingo. And those two things have to be equal. Okay. So the y value at the starting point of the interval has to equal the y value of this ending point of the interval. Okay, a and b goes to f of a equals f of b. If you've met those 3 conditions, it's continuous, it's differentiable, and you start and stop at the same level, then this other stuff is true. And what's the other stuff? F prime of c equals 0 for at least c in an interval. In other words, there's one spot in that interval that f prime of c equals 0. What does that mean? Say it again.
Has a horizontal tangent.
Good. Now, the derivative is equal to 0, which means it has a horizontal tangent. Which translates into what graphically?
Basically, it starts and ends at the same height. It has to go horizontal at some point.
Yeah. Good. Or? Or a maximum. Yeah, it could be either one. Okay, now how do you remember this? Well,
It's very easy.
the following. I have to start at the same level. Okay, so I'm going to start here at A, and I'm going to end here at B. And they have to be at the same y value. And then you've got this little function that we're just going to call a hill. So this function is continuous. I just drew it without picking up my pen. It's differentiable, because it is. And we're starting at the same level. So I've satisfied all three conditions. The way you're going to remember this is you're going to take this ball and you're going to roll it up the hill. See where I'm going with this? I'm going to roll it up the hill. So if I start at level ground, I knew you'd get there eventually. If I start at level ground and I roll this ball, okay, just to make sure we're all on the same page.
It's not on the same page.
I'm rolling a ball and it's Rolle's theorem.
Yeah, that took me a while.
I never know.
Anyways, I start at level ground, I roll the ball up the hill, and then I roll it back down to level ground again. At some point, I've got to hit the top of the hill. Does that make logical sense?
Yeah.
Okay, good. That's all the theorem says. If you go from A to B, on level, going from level ground to level ground, somewhere along the line, I've got to hit the top of the hill, or as Vince mentioned, you've got to hit the bottom of the well. Because we could be talking about a maximum or a minimum. Here's A, here's B. We roll the ball down into, ooh, that's, you got to hit the bottom of that pit at some point. Question?
So it's just saying like, I don't know what point it is, but somewhere it's there.
Good. Yeah. Rolle's theorem isn't telling you where it is. It's just saying there's got to be a point somewhere in there. You go from level ground to the top of the hill and back down. You got to hit the top of the hill somewhere. You can't get from point A to point B without hitting the top of the hill or the bottom of the valley.
But this relates,
Okay.
but the point will somehow relate to extreme.
Say
The
again.
point will somehow relate to an extreme.
Yeah. Okay. So Sydney just mentioned something that's relevant that is going to work into our transition is that point that we're looking for, and Vince mentioned this also, that point becomes an extremum. So if it's a hill, we're looking at a maximum, and if we're looking at a valley, it becomes a minimum. Okay, that's all Rolle said. Rolle just said it's got to be in there somewhere.
Wow, that's me.
And then we, what's that?
That's me. Like, it has to be there somewhere.
Right. Yeah. Good luck.
Neither of you can figure out.
Trust me, it's there.
Yeah, anyone can make a theory.
Yeah. But of course, we're going to do more than that.
It's
And
there somewhere.
the problem with Rolle's theorem is that it pigeonholes you into being in a very specific situation, and that is this idea that you're starting and stopping at the same level. We don't want to do that. And so once we get done with the Rolle's theorem example, then I'll take you through mean value theorem, which will allow you to do that. Okay, so there it is in English, but we did it in English already, so let's do this. Okay. Yuri, what can you tell me about that function? What can you tell me about f of x? Anything. Good. What else? Good. It's continuous. How do you know it's continuous? You just know. Good enough. What else?
What are you asking?
It's an open-ended statement. What else can you tell me about that function? If you have nothing else, then say I got nothing else. I'll go pick on somebody else. Really? You don't know what it looks like?
It's an Ebola.
Looks like a U, also known as. It's a. Does it open up or down? Up. Why? Good. Okay. So it's a parabola that opens up. If it's a parabola that opens up, will it have a max or a min or neither? Min. Okay. Good. Could you tell me where the vertex of that parabola is? Using your vast stores of pre-calculus or advanced algebra knowledge.
3/2.
Okay, sure. What did you just do to find that?
Negative b over 2.
Good, negative b over 2a. So we can actually solve this problem using pre-calculus. We're not, we're going to use calculus. But the vertex then would be the minimum, right? So you just solved the problem. We're going to use calculus, however, to reach the same idea. On the interval from 1 to 2, so we've established, you told me it's continuous. Is it differentiable? Good, because it's a polynomial and polynomials are differentiable. Okay, so it's continuous, it's differentiable. Are we starting and stopping at the same point? How do we check that?
Plug in ends.
Be more specific.
Endpoints. 1
Good.
and 2.
Let's find f of 1 and f of 2. If this doesn't work, then we're done. If they're not the same value, then Rolle's theorem doesn't apply and we move on. And that could happen. In this case, however, if I plug in 1, I get 0. And if I plug in 2, I get, sure enough, 0.
Wow.
Yeah,
Crazy.
It's like magic.
that's where I planned that. We've met all 3 conditions now for Rolle's theorem. It's continuous, it's differentiable, and it starts and stops at the same point. So Rolle's theorem then said, somewhere in there, you've got to hit a peak or a valley. Top of the hill or bottom of the pit. And Yuri already used pre-calculus to find that point. We're going to use calculus to find that point. How do I find the point? Max.
Find the derivative and set it equal to 0.
Beautiful. Find the derivative, set it equal to 0. Well, look at that. That's the same answer that Yuri had.
Wow.
Even though we solved it for x, they commonly call those numbers c values. It's the point on the interval where this stuff happens, where it hits a peak, hits a valley. It's an extrema. That kind of thing. It is possible to have more than one point, depending on the interval that you're looking at. This is a parabola. It's only got one minimum. But if the function becomes, let's say, a cubic or a quartic, you know, you might have you might have a weird quartic like that, where you could have more than one c value in that interval. Okay, does that make sense? You have to check each one of these things that it satisfies the first 3 conditions. If it doesn't, then you just move on. If these weren't the same values, then you move on. Okay, and Rolle's theorem doesn't apply. Are we good with that? Yes. Okay, good. My pen is totally crap. Okay. I'm just going to walk over here. I'll come back over here. Getting a little exercise today. What did I just miss? Oh yeah, yeah, we did that already. Great. Okay. Yeah. 3 halves. Excellent. Great. Match. Mean value theorem. Like I said, Rolle's theorem is too restricting. We have to start and stop at the same point. Mean value theorem expands that and lets us look at any function on any interval to find those weird points where things happen. One way you can think of mean value theorem, and this will make sense once I get to the actual problem, is we're going to take Rolle's theorem and tilt it or revolve it. So instead of starting and stopping on level ground, we might turn it this way, or flip it upside down, or do all kinds of weird things with it. Okay, so 2 things now we need. Only 2, continuous and differentiable. Easy. We don't care about starting and stopping at the same point. Still looking at an interval from A to B. And this, I like this version better, but you could also do this version. It's just simply multiplying by it. Is the mean value theorem. So let's start with the left side of that equal sign. What's the left side of that equal sign say? And don't tell me f prime of c, I can read. What does that mean? What is f prime of c? Not necessarily. Not numerically. What's f prime mean? Derivative. So what's the derivative at c mean?
The slope of the tangent line.
Beautiful. Slope of the tangent line to the graph at c. What's the right side of the equation? You're probably not used to seeing it in that form, but you've seen it. You've done that so many times you can't even imagine.
y2 minus y1 over x2 minus x.
Say again, Kev?
y2 minus y1 over x2 minus x.
Also known as
Slope.
slope. Okay. So the mean value theorem, conceptually, the way you're going to remember the mean value theorem is this thing in red. the slope from calculus, f prime of c, has to equal the slope from algebra. And for those of you that are visual learners, I've got a picture for you. And I'll explain this picture in a second. Slope from calculus equals slope from algebra. So as soon as somebody mentions MVT, you're going to go right to this. Slope from calculus equals slope from algebra. All right, so what I've done is I took these 2 points. These are the endpoints of my interval going from A to B. So this is B comma f of B, this is A comma f of A, and calculated the slope of that secant line. The mean value theorem says that somewhere in between those points, I have to be able to get a tangent line that has the same slope. So now we're talking about parallel instead of being horizontal. If you can visualize that, this is what I was talking about taking Rolle's theorem. If I take this picture, this is a visual, and I flip it over so that this line is horizontal, we get a version of Rolle's theorem. So mean value theorem allows us to take Rolle's theorem and spin it to make any type of line. Doesn't have to be horizontal now. Calculate the slope of that line, which is a secant line, using algebra. Calculate the slope of that line using calculus. Set the two things equal. You're good to go. It's a fairly algorithmic approach. You just need to see what that looks like. Are we good with this slide? Yeah. Okay. So here's my function. I've got an interval from 2 to 7 of the function 5x squared minus 30x plus 52, which is a parabola. Is it continuous?
Yes.
How do you know?
I just know.
I'm sorry? It's polynomial. Is it differentiable? Yes. How do you know? Because it is. Good. There's nothing there that's going to create any problems. So I need a couple things. You want to do the algebra or the calculus first? The algebra first? Okay. So if I'm going to do the algebra first, I need the endpoints. Wow. Where did that come from? All right, what's f of 2? You might want your calculators, by the way, depending on how good you are.
Well,
12. What's f of 7? $87. Beautiful. Now I know my stopping point and my starting point, which means I'm going to start by calculating the slope of the secant line, which is just y2 minus y1 over x2 minus x1. 87 minus 12 over 7 minus 2, which is 75 divided by 5 is how much? 15. Good. Okay, so I've got a secant line on that parabola that has a slope of 15. Okay, that's the first part. That's the slope from algebra. Now we have to do the slope from calculus. What's the slope from calculus? Yeah, the derivative. So f prime of x is 10x minus 30. Not a numerical value, an equation value. And now I have to set these two things equal because the slope from algebra has to equal the slope from calculus. Whoops. So x is equal to 4.5?
Yes.
Yeah, okay, good. Now what does that mean? It's one thing to be able to solve the numbers. It's another thing to understand what I just solved for. What is special about the x value of 4.5?
that's where the tangent line equals 15.
That's where
The slope of the tangent line equals 15.
slope of the tangent line equals 15, which is the same as the slope of the secant line that passes through. Good. Not a bad process. The numbers aren't that bad. The derivatives aren't that bad. You just have to remember to set the two things equal, not plug one into the other. Common mistake is people get this, and then they plug it into the derivative. You don't want to plug it in. You want to set it equal because the slope from algebra has to equal the slope from calculus. Oh, by the way, I forgot to mention this. Before you start a mean value theorem, just like Rolle's theorem, you have to make sure that you've met the necessary requirements, and that is it has to be continuous and differentiable. And even if you know it's true, you still need to make a statement. The function is continuous and differentiable. Most of the time it's going to be the function is continuous and differentiable because it's a polynomial. And then move on to the calculations, which I have all those right here, which we got the same answer on.
So do you actually have to write?
Yeah, they're real big on writing sentences. You freezing? You want a blanket? Or let me close the window?
I'm cold too.
No, because then if I say close the window, then they're all gonna be like, it's hot in here.
No, I'm very cold.
Guys, it's fresh air.
I was just out.
One of you back said the blanket. One of you guys said you had a blanket, Juba.
Problem solved. There was
Way
that.
to go, it's when I was gonna get hot.
It's all your fault.
Oh my God.
Only the window is open.
I'm just gonna.
Another example. Something that's not so pretty as a parabola.
Like you.
Okay, we have this gross function, 5 minus 4 over x, and we want to find the c values on the interval from 1 to 4. So I started with the mean value theorem. First of all, we need to answer the question, is it continuous?
Yeah.
Well, there it is right there. It's continuous. Good. Is it differentiable?
Yeah.
Yeah, there's nothing in that interval that's going to cause it to be a problem. There's no vertical tangents. There's no corners. There's no jumps, discontinuities. So we're good to go. Satisfy the hypothesis. Now we move through the problem. Find f of 4. Find f of 1. Calculate the slope. Okay, we did that already. And then here's all the work. Hold on a second. Let's go back. For those of you that are visual learners, I'm going from 1 to 4, and I want to know where in this interval will the tangent line be equal to the slope of the line going through my fingers. How many answers will I get? 1. It's somewhere over here. Does everybody see that? Okay, good. However, when I plug in all the numbers and do the work, you will see that I get 2 answers. How is that possible?
Because it's not right. It's
Kind of.
That doesn't make sense.
squared.
No?
Can you both have positive and a negative slope
Yes.
It would break the
in the
theorem.
same line?
Say again?
Like, can a line can't have.
A line? No. A line can only have one slope.
2.
Get it.
Kind of.
2 lines have 2 slopes.
Just saying it again doesn't make it more true. Or saying it louder. You saw from the graph I should only get 1 answer, but the math is showing me 2 answers. Why?
Extraneous.
What makes it extraneous? You're on the right track.
Because wouldn't the line be like this was positive?
So you're saying we're only going to take the positive answer here?
Yeah.
Why?
Because negative slopes go this way, right?
Correct.
And that's not the slope of the function.
For that picture.
Yeah.
What if you didn't have the picture? How would you know that 2 is the correct answer and not negative 2?
I don't know.
Because I don't know.
Yeah.
You just plug it somewhere?
I can.
It's easier than that.
Oh.
Look in your notes. Look at the original problem. What does the original problem say?
Negative.
Oh, because the interval is from 1 to 4.
Yep, the interval is from 1 to 4 and negative 2 is not in the interval. Okay, told you it's pretty simple. That happens a lot. So you have to realize that even though the mathematics shows you that you have 2 c values, You're actually only going to take one of them because only one of them is in the interval. So the interval determines everything. It's not over the whole function. It's just on the interval. And in fact, we'll see some functions that are discontinuous at certain points. That doesn't mean you just throw out the MVT. It means you have to look at the interval we're working with. As long as the function is continuous and differentiable in the interval, you're good to go. Does that make sense? Okay, good. So again, you got to be careful that don't just blindly go with whatever answers you get. You got to be a little bit more selective. And we're done. That's an actual bridge. I think it's in China. They thought it would be a good idea to put the mean value theorem on a bridge in China because they appreciate